using intercepts to graph linear equations. Your learning target, you will find the x and y intercepts of a linear equation algebraically and use them to graph a linear equation. You will model with mathematics. So let's graph this equation, y equals 3x plus 2. Recall, this equation is in slope-intercept form, so we certainly could put our first point on the y-axis at 2 and then use the slope up 3 to the right 1, up 3 to the right 1 to graph our other points. But we could also use a table of values, and we could choose values for x, such as x equals -1. Now do some mental math. When x equals -1, what does y equal? Y would equal -1 also. And here's the work to prove it. Y equals 3 times -1 plus 2. That's -3 plus 2. Y equals -1. When x equals 0, what would y equal? Again, use mental math if you can. When x equals 0, y equals 2. When x equals 1, y will equal 5. Now we're going to graph these 3 points, and they should all lie in a straight line. And now we will connect these points because linear functions are continuous. So that particular equation, our approach to graphing it, because y was already isolated, was to make a table of values. So here's our next equation. This one is in standard form. It is still a linear function because x and y are to the first power. However, y is not isolated. So we will use a table of values coupled with intercepts. Now to find the y-intercept, we're going to set x equal to 0. And when I do that, 2 times 0 plus 3y equals 12. 3y equals 12, so y equals 4. Okay, let's plot the y-intercept. Now to find the x-intercept, we'll set y equal to 0. So 2x plus 3 times 0 equals 12. 2x equals 12, so x equals 6. Let's plot that x-intercept. And let's connect those 2 points. Now what made using intercepts very convenient in this case was because the coefficients of x and y are compatible with the 12 that the equation had. So keep that in mind. Look for that structure going forward. We'll try another example. So same thing, this equation is not solved for y. So we'll make a table of values. And because the coefficients of x and y are compatible with -20, we'll use intercepts to graph this line. Okay, let's find the y-intercept by setting x equal to 0. Can you do that? Can you find that y-intercept using mental math now? If x equals 0, you'll be left with 2y equals -20 or y equals -10. All right, what about the x-intercept? Substitute 0 in place of y. Can you do that using mental math? -5x equals -20, x equals 4. So now plot that x-intercept and connect your 2 points, and there is your linear function. We'll try another example. This one is not as convenient as the other two, so we'll find out why that is in just a moment. But to find the y-intercept, we set x equal to 0. So here you see, when we solve for y, it will not be an integer value. Because -3 times 0 is 0, you'd end up with -2y equals 9, so y equals -4.5. So that's a little bit harder to locate on your coordinate plane. It's between -4 and -5 on the y-axis. All right, let's substitute 0 in place of y and find our x-intercept. -3x minus 0 then equals 9. -3x equals 9. x equals negative 3. And we'll plot that on our x-axis. We'll connect those 2 points, and there we have our linear function, negative 3x minus 2y equals 9. So just to refresh your memory and summarize what we've done here, this is how we graph a linear equation using intercepts. Notice we made a table of values. We set x equal to 0 to find the y-intercept. We set y equal to 0 to find the x-intercept. We plotted the intercepts, we connected the points with a straight edge and extended the line beyond the points and added arrowheads. And you should always label your equation with the equation next to the line. So let's check, is your learning on track? Can you graph an equation in standard form like this one, negative x plus 4y equals negative 8? How would you find the intercepts and use those to graph that function?